In this video, we are learning how to factor the difference of two squares, and this is just a special case when we're factoring. So let's jump into example 1. So we have x squared minus 9, and the reason this is the difference of two squares is because both x squared and 9 are both perfect squares. So they're both perfect squares, and we are taking the difference between them because we are subtracting them. So if you ever have a factoring problem where you have two terms, and they are both perfect squares, and you're finding the difference between them, we're going to use this rule called the difference of two squares. So the way we're going to factor this is we're going to set up two sets of parentheses. And in the first part of each set of parentheses, we need to take the square root of this first term. So the square root of x squared is x. So we're going to put an x in both of the first spots. And then in the second spots, we are going to take the square root of the second term. The square root of 9 is 3. So we're going to put a 3 in both of those spots. And now we're going to put a plus in one of the parentheses and a minus in one of the other parentheses. And that's how we factor it. And so we're finished. And if you want to check that this works, I'm going to refoil this out to show you guys why this works. So if I want to refoil this out, I'm going to multiply x by x, which is x squared. Multiply x by negative 3, which is negative 3x. Multiply 3 by x, which is positive 3x. And multiply 3 by negative 3, which is negative 9. And what you're going to notice is that this negative 3x and this positive 3x cancel out and go to 0. So that's how we're just left with this x squared minus 9. So that's why the difference of two squares works. So now let's try example 2, which is 16x to the fourth minus 81. So 16x to the fourth is a perfect square and 81 is a perfect square. So we're going to start by drawing our two sets of parentheses. The square root of 16 is 4, and the square root of x to the fourth is x squared. So the square root of 16x to the fourth is 4x squared. That's going to go in the first spot of each parentheses. And then the square root of 81 is 9, so we're going to put a 9 in the second spot of each parentheses. We're going to put a plus between one of them and a minus between the other. And now you may think we're finished, but this second set of parentheses is actually another difference of two squares. So we're actually going to have to factor that right set of parentheses again. So down here, I will write 4x squared plus 9, and now we have to factor 4x squared minus 9. So we're going to take the square root of 4x squared, which is going to be 2x, put that in the first spot in each parentheses, take the square root of 9, which is 3, put that in the second spot, put a plus between one and a minus between the other, and now we have our final answer. And you may be thinking, well, why can't we factor 4x squared plus 9? And that's because that is not the difference of two squares. That is the sum of two squares, and there's no way to factor that. So we can only factor the difference of two squares. So now let's take a look at example 3, which is 64x to the sixth minus 25x to the fourth. So what we always want to do when we are factoring is see if we can pull out anything that our terms have in common before we jump into the next steps of our factoring. So you may notice that x to the sixth and x to the fourth both have an x to the fourth in common. So we're going to start by pulling out an x to the fourth. And if we do that, we're going to be left with a 64x squared minus 25. And now we're going to factor 64x squared minus 25 using the difference of two squares. So down here, we're going to keep x to the fourth on the outside. The square root of 64x squared is 8x. We're going to put an 8x in the first spot of both of our parentheses. And the square root of 25 is 5, so we're going to put a 5 in the second spot of both of our parentheses, put a plus between one of them, a minus between the other, and we cannot factor either of those anymore, so we know that we're finished. Moving on to our final example, we have 12x to the fifth minus 300x to the third, and I encourage you guys to pause the video and try this one on your own, and then you can watch me work through it to make sure that you've solved it correctly. So let's start by pulling out what these two terms have in common. They have a 12 in common and an x cubed. I'm going to take out a 12x cubed. If I divide 12x to the fifth by 12x cubed, I'm left with x squared. And if I divide 300x cubed by 12x cubed, I am left with a 25. So I have 12x cubed times x squared minus 25. And now x squared minus 25 is the difference of two squares, so I can factor that using the rule we've been using. So I'm going to keep the 12x cubed on the outside. Take the square root of x squared, which is x. That's going to be in the first spot of both of our parentheses. Take the square root of 25, which is 5, and put that in the second spot. Put a plus in one set of parentheses and a minus in the other. So we get our final answer as 12x cubed times x plus 5 times x minus 5. So hopefully this video helped you guys understand how to factor the difference of two squares. If you want some more practice with problems like these, check out the link in our description for a free practice worksheet.